Let's have a look at this question. When light is shined on a mixture of chlorine and ethane, chloroethane is formed. Besides dichloroethane, trichloroethane and several other products, what reaction condition can optimize the yield of chloroethane? And we have been given 4 options. The first thing that we have to know is which reaction is this? So light is being shined on a mixture of chlorine and ethane. Well, this is what? This is the halogenation reaction. Right? We have ethane plus Cl2 in the presence of light. So this is H nu. What happens in the halogenation reaction of alkanes? So one or more than one hydrogen atoms in the alkane, they are replaced with the halogen atom, which is what? Chlorine atom in this case. So we'll get CH3, CH2, Cl plus HCl. However, the reaction does not stop here. So we get multiple products such as CH3, CHCl2, CH3, Cl3, right? So there are many byproducts formed in this reaction. So if we want to increase the yield of chloroethane, we first have to know how this reaction happens. What is the mechanism behind it? Well, it happens through free radical mechanism. And free radical mechanism occurs through 3 steps. The first step is the initiation step. So we have Cl2 molecule. So the bond between 2 Cl atoms, it undergoes homolytic cleavage to give 2 chlorine radical. This is the initiation step. So in the second step, which is the propagation step, this chlorine radical reacts with ethane that is present in the reaction mixture to give what? To give CH3, CH2 free radical plus HCl. Now this CH3, CH2 free radical, this will combine with Cl2 that is also present in the reaction mixture to give what? CH3, CH2, Cl plus Cl radical. Right. So this is what? This is a propagation step that is happening. Now this CH3, CH2, Cl, this molecule can also react with Cl free radical to give what? To give CH3, CH, Cl free radical plus HCl. Now this free radical that is formed, CH3, CH free radical Cl, can react with Cl2 to give you what? To give CH3, CHCl2. That is what? Dichloroethane. Similarly, just like these 2 reactions, you can also get CH3, CCl3. That is what? Trichloroethane. Right? And the third step is what? Third step is termination. So the 2 chlorine free radicals, they can combine to give what? To give chlorine gas. So in the termination step, what happens? The concentration of free radical decreases. Right? So here CH3, CH2 free radical, that will combine with another CH2, CH3 free radical to give what? Butane. So there are lots of byproducts that are formed in this reaction. However, we need to know how can we increase the yield of chloroethane. Right. So how can we do that? Okay, let me propose to you something. If we have high concentration of ethane, right, high concentration of ethane present in the reaction mixture, then this Cl free radical, the possibility of this Cl free radical to abstract hydrogen from ethane will increase. So let's say the population density of ethane is more, right, as compared to what? The chloroethane or dichloroethane, right, present in the mixture. So Cl free radical will have higher possibility to abstract hydrogen from ethane, which will lead to the formation of ethyl free radical, which will in turn react with Cl2 to give what? To give chloroethane, which increases. So if the possibility of Cl free radical, right, increases to react with CH3, that is ethane, then the yield of chloroethane will also increase. Why? Because Cl free radical might react, let's say, just for an example, let's say out of 10 times, right, out of 10 times, Cl free radical is reacting with ethane 7 times. and maybe 1 time with chloroethane and maybe 2 time with dichloroethane, right? So if it is reacting maximum with ethane, then we'll get higher concentration of chloroethane. And to ensure that the chlorine free radical reacts maximum with ethane, what would we have to do? We have to increase the number of molecules of ethane in the reaction mixture, or we have to the number of molecules per unit volume. So that is what? That is the concentration. So if we increase the concentration of ethane in the reaction mixture, then the Cl free radical will have higher probability, not possibility, probability of reacting with ethane, which increases the yield probability of what? Of the production of chloroethane, which will give us what? It will give us higher yield. So the correct option out of these 4 options that is given to us is what? Higher excess. So higher concentration of ethane or excess of ethane reactant. Let's have a look at this question. Arrange the compounds in the order of decreasing boiling points. First is ethanol, second is propane, third is pentanol. Okay, so decreasing boiling points that we have to find, and we have been given 3 molecules. So first is ethanol. All is alcohol functional group and eth is 2 carbon atoms. So what do we have? We have C, C and OH. I'm just writing the skeleton. I'm not giving them hydrogens. Okay, just writing the skeleton. Next is what? Next is propane. That is alkane. And prop is what? 3 carbon atoms. So we have C, C and C. Third is pentanol. All is alcohol functional group and pent is 5 carbon atoms. So we have 5 carbon atoms and alcohol group. So this is 1, this is 2 and this is 3. Okay. Now, first thing that we need to know is what factors does boiling point depend upon? Well, boiling point is directly proportional to surface area. So more the surface area, more will be the boiling point, because more are the van der Waals forces. Okay, more the forces of attraction between the molecules, more energy you'll have to give it to break those interactions. And more energy, how do you give? Through temperature, through heat. So more the heat is, if more heat is to be given to break those intermolecular forces of attractions, then that makes it what? That makes it high boiling point, right? Because you have to give it more heat, high temperature. Okay, now surface area, what can we say about branching? Well, boiling point is inversely proportional to branching. So if you have, let's say, 5 carbon atoms, okay, and I can arrange them. If we branch them, we can get this as well. These are what? These are the 2 isomers of pentane, right? So, okay, so in this case, the case that we have is 2,2-dimethyl propane, right? In this case, there is branching. The molecule is compact. Surface area is less. Surface area is less, so van der Waals interactions is less. Then you have to give less heat to break those interactions. That means the boiling point is less. Okay. What else does it depend upon? So boiling point is directly proportional to molar mass. And we usually factor in this molar mass when we have, if we have molecules which have the same functional group. Okay, and we have already established what? By boiling point is directly proportional to what? Van der Waals interactions. Okay, so since after knowing all these factors, now let's assign which of these 3 molecules will have highest boiling point. Okay, so first if we look at the options, what do we have? We have alcohol and we have alkane. Okay, so we know that alcohol is going to have higher boiling point than alkane. Why? Because alcohol would have hydrogen bonding, and hydrogen bonding is what? It is the strong van der Waals forces. Okay, so alcohols is always going to have higher boiling point than alkane, because more hydrogen bonding, more the intermolecular forces of attraction, more the heat that would be required to break those interactions. Okay, so we know that first and second are going to have higher boiling point than second. First and third will have higher boiling point than second. So second would have the least boiling point. That is clear. Now, out of ethanol and pentanol, out of these two, which will have higher boiling point? Now, in this case, we'll factor in molar mass, because molar mass factor that we use when we have same functional group. And since both of these compounds have only one OH group, so if you just talk in terms of OH group, the interactions are going to be almost the same. But what about the boiling point? Well, more the molar mass, higher would be the boiling point. And if we have 5 carbon compound, if we have 3 carbon compound, which compound will have higher boiling point, or which compound will have higher molar mass? 5 carbon atom, correct? So the highest boiling point will be for compound 3, then followed by compound 1, and then followed by compound 2, which is alkane. Let's see which option does it match. That is 3, 1 followed by 2. That is option B, which is the correct option. Let's have a look at this question. Which of the following statement is not correct? Okay, so let's have a look at the first statement, that is combustion of alkanes in the absence of sufficient amount of air is called incomplete combustion. Okay, so first let's try and understand what combustion is. Combustion is of 2 types. One is the complete combustion, another is incomplete combustion. Okay, in complete combustion, what happens is the alkanes react with sufficient amount of air to give what? To give CO2, water, and enormous amount of heat is evolved in this reaction. However, in case of incomplete combustion, what happens is the air that is not sufficient for the alkanes to react with. So it leads to the formation of carbon or carbon monoxide. This is what we know about combustion and incomplete combustion. So now let's move on and let's check what option A says. So option A is combustion of alkanes in the absence of sufficient amount of air is called incomplete combustion. Yes, we just arrived at, we just discussed that. Yes, this is the correct statement. Okay, next statement is combustion of alkanes in the presence of sufficient amount of air is called incomplete combustion. Well, no, that is the complete combustion, right? So option B is absolutely wrong statement. Okay, so option C says during incomplete combustion of alkanes, carbon black is formed. Yes, that is one of the product. So yes, this is the correct statement. Option D says all of the above. That is, all of the above statements are not correct. That is absolutely wrong. So now we know the statement which is not correct is option B, and that is the correct option. Let's have a look at this question. Which one of the following statements is true regarding solubility of alkanes? Okay, so what do we know about solubility? We do know that like dissolves like, right? And what are alkanes? Alkanes are non-polar in nature. So after knowing this information, let's move on to the statements. So option A, statement A is that alkanes are insoluble in water. That is true. Why? Because water is what? Water is a polar molecule because of the electronegativity difference between oxygen and hydrogen. Large electronegativity difference, right? So this makes the option A absolutely correct. Yes. Why? Because alkanes are non-polar. Water is polar. So alkanes will be insoluble in water. Okay, so next statement, it says soluble in various organic solvents. So organic solvents, organic is what? Organic is the compounds of carbon, right? So the compounds of carbon, the electronegativity difference in between them would be much less, right? So we generally consider organic solvents as non-polar, and alkenes are non-polar, so non-polar will be soluble in non-polar, correct? So yes, statement B is also correct. Option C says both A and B. So yes, that is correct. Option D is none of these, which is not correct. So the ultimate option, which is the correct option to this question, is what? Option C, which says that both option A and option B are correct. Let's have a look at this question. Write the correct reactivity order towards the photochemical chlorination. X is what? X is N-pentane. Y is isopentane. Z is N-butane. No, my bad. It is isobutane. And W is what? Ethane. Okay, and we have been given the orders in the 4 options. Okay, so what do you need to know to solve this question? Well, first you need to understand which reaction is this. We have 4 molecules, 4 alkanes given to us, and this is what? Photochemical chlorination. So this is halogenation reaction of alkanes, right? And we have to find out the reactivity order. Well, the first thing that you need to know is that the halogenation reaction of alkanes follow which mechanism? It follows free radical mechanism. And the molecule out of these 4, the one molecule that has this most stable free radical in their mechanism will have what? Will have the highest reactivity, right? So let's have a look at all these 4 molecules given to us, and let's find out which molecule has the highest, which molecule has the most stable free radical and which molecule has the least stable free radical. So the first one is what? First one is N-pentane. So that would be CH3, CH2, CH2, CH2 and CH3. Okay, so what would be the most stable free radical in this molecule? Well, it would be this free radical. Why? This is 2-degree free radical. Along with this, how many alpha hydrogens does it have? It has 5 alpha hydrogens. Okay, before coming on to this, what is, I hope you remember the stability of free radical. Well, 3-degree free radical is more stable than 2-degree free radical, is more stable than 1-degree free radical. And the free radical which has more number of alpha hydrogens is more stable. That's what we have to remember. Okay, I'm just writing it here so that for your reference you can look at it. Okay, so next option, next molecule that we have. Okay, so these are given the names. Let's give name only. So this is what? This is X and this is Y. And Y is isopentane. Okay, so we have C here, C here, C here. So CH3, CH3. Here we have H. This will be what? This will be CH2 and this will be CH3. Okay, so in this molecule, in Y molecule, which would be the most stable free radical? Well, this would be the most stable free radical. Why? Well, this is 3-degree free radical and it has how many alpha hydrogens? It has 8 alpha hydrogens. Okay, now let's have a look at molecule Z. That is isobutane. Okay, so we have CH3, CH3, CH3 and here we'll have H. Now, what the most stable free radical in this molecule? That would be what? That would be this free radical. So this has what? This is 3-degree free radical and how many alpha hydrogens? It has 9 alpha hydrogens. What about option or molecule W? That is ethane. Okay, so in this case, what would be the most stable free radical? That is CH2 free radical, right? So if you make it on carbon 1 or carbon 2, it's the same, right? Because that's going to be carbon 1. Okay, so this is what? This is 1-degree free radical, right? Why? Because it is the free radical carbon, the carbon on which the free radical is there is connected to only one carbon atom. And how many alpha hydrogens does it have? It has 3 alpha hydrogens. Now, this information is enough for you to understand or to come to the correct reactivity order. So what did we say? We said that the most stable free radical will lead to highest reactivity. So which is the most stable free radical? Let's give them the order. So that is what? That is 3 degree 9 alpha hydrogens. That is the first one. After that will come what? Will come 3 degree free radical, right? But it has 1 less alpha hydrogen. So this will be second in order. What would be the third one? Well, that would obviously 2 degree. So this will be third in order, and the least reactive would be ethane, right? So the what is the order that comes out to be? So that is Z has the highest reactivity, followed by Y, followed by X, and then followed by W. Let's see which option does it match. X, Y, sorry. That is Z, Y, X, W. Z, Y, X, W is which option? That is option B, which is the correct option.